So now we'll do an example using the t-test. And this has to do with lead content taken from 12 water specimens. So we have 12 samples here. And we're really looking for if the lead content is above 2.25 micrograms per liter. So we're looking, we don't really care if the lead levels are less than that, but if they're more than that, we definitely want to know. So we have these samples here, and we're going to test the null hypothesis, which says the mean is 2.25. That's the critical level that we're looking at. We don't want lead levels to be any higher than that. And then we're really concerned if that mean is above 2.25. And we're going to use a level of significance or the alpha value of 0.025. Okay. And one thing I didn't mention, but we need to be careful about, we need to make sure that when we're doing this hypothesis testing, that the data actually follows a normal distribution. If it doesn't follow a normal distribution, then we shouldn't be doing this hypothesis testing, because all of the tests that, or the criterion that we use, the assumption is that the data follows a normal distribution. So the first thing we need to do is calculate the mean of the sample. So we have 2.483 and the standard deviation here of 0.3129. So this, our sample standard deviation, or our sample mean here, our sample mean is bigger than 2.25, but we just need to figure out is that significant, or is it just a consequence of randomness of how we selected our sample? So that's how we're going to test the hypothesis here. So first thing that we need to do is define our hypothesis. And so it's given here that mu is equal to 2.25. That's our null hypothesis. And then the alternative hypothesis would be mu is greater than 2.25. That's really where we'll be concerned about the lead levels here. Okay, so first thing, we have our defined hypotheses here, the null and the alternative. And then we need to check our criterion that we're going to use. And what we see here is our alternative hypothesis looks like this. It's a greater than symbol here. So what we're going to use to check is this T is greater than T alpha. So proceeding from here, we have a level of significance, alpha equals 0.025, and we can look that value up in the table in our book. So we look for T 0.025, and we have the degrees of freedom here. We have 12 total samples. We subtract 1 from that, we get 11 degrees of freedom. So on the column, we would look at 11, and then look at 0.025 for alpha, and we'd come up with this value, this T value. And proceeding from there, we calculate T. So we use this formula for T, and then we have our mean here of our sample, and we subtract off kind of the value in our hypothesis here, 2.25, and divide that by the standard error here. And we get T of 2.58. And from here, we just plug this into our test. So we're checking if T is greater than T alpha. So in our case, we have 2.58 is greater than 2.201. So it satisfies this condition, so we reject the null hypothesis. So we're rejecting the null hypothesis, and so that means that leads to the conclusion the mean lead content is above 2.25 micrograms per liter. So we should be concerned about this. So we should probably take some action to maybe examine further the lead levels, or possibly do some way to clean up the lead levels in the water supply. So since we're only testing the greater than condition, we call this a one-sided t-test, because we're really only looking for if our lead content is above a certain level. And we can actually calculate our p-value, and our p-value, remember, is the area underneath that curve here. So, and the p-value comes out to be 0.013, and then this means that there's a 1.3% probability the mean is actually equal to 2.25 micrograms per liter. So that's a small percentage. That's a very small percentage. What is the most likely thing is that our mean is above 2.25, so it's at a concerning level. So since the p level is less than our alpha, we reject the null hypothesis. Our results show an excess of lead in the water. Now the p-value is not, we could look that up for our z-values if we were using the z-test, but in our book we're not able to calculate this p-value when we're doing a t-test here. So you can use an online calculator if you wish. Here is an online calculator to calculate the p-value from a t-score. So our t-score, what we calculated is 2.58, so we can put that in there. And our degrees of freedom, remember, is 11. And they don't have the significance level that we used in our example problem. But we do need to select if this is a one-tailed or two-tailed test, and this is actually a one-tailed test. So we can hit calculate, and our p-value comes out to be 0.0127, which is roughly 1.3%. So it's roughly 1.3% here.